My goal in this video and in the series of videos I'm making about percent change is to get you to stop doing what I see students typically do when presented with percent change problems, to rebuild your approach to them that will make you more flexible and able to answer even the hardest percent change question you might see on an SAT, an ACT, or wherever. So let's start slow with a simple problem, and I want to show you the typical approach students take to this and what I think you should do instead. And in future videos, I'll explore more about why I think, even though the approach I'm going to show you first does work, why it's a bit rigid and it's not going to be helpful for you, especially on those harder problems. So here we have sales tax at 7%. The price of the TV is $200, and we want to determine the total price, including the sales tax. So here is the typical approach that I call the two-step method that students take for solving these kinds of problems. They start with the $200. And they say, okay, well, it's a 7% tax. So what I'm going to do is find 7% of 200. And they'll often do something like this. They'll go to the calculator, do 200 times 0.07. So 7% of 200 is 14. And we get the result here. We say, okay, if you're not careful, you might put 14 as the answer. But this is 7% of 200, not 7% more than 200. So what often then is done is the second step of the two-step method is to take this result and add it back to the 200, right? Add it back to where you started. So we're going to add that increase, and we get $214. And that's correct, right? Nothing wrong with that from a math perspective. It is totally fine. However, as we'll see in future videos, this method is just not flexible enough or reliable enough for the harder questions you're going to see. And I think many students struggle with percent change because they're trying to fit this approach into those harder problems. And you can do it, it's just very awkward. So what do I recommend instead? I recommend using this formula, this shortcut, if you want to call it that, that we're going to use on any percent change problem, increase, decrease, that we see. And it looks something like this. You start with your initial number, which we'll call n, and you multiply it by 1 plus or minus r. So n is that original number, and r is that percent increase or decrease. So it's the percent change. And then plus or minus, it's plus if it's increasing, minus if you're decreasing by that percent. So you may think, well, this is not that much quicker than the previous method. Well, I don't know. I think it's quicker, right? It's one step instead of two. And it'll be so helpful on the harder questions. And actually will be helpful on any questions involving exponential change, because exponential change is in many ways just repeated percent change. So how would that work here? We would take our 200, which is our initial price, and we would go ahead and multiply that by 1 plus, because we're increasing by 7%, 1 plus 0.07. Remember, when you're using these percents in any kind of calculation, you have to turn them into their decimal form or fractional form, right? So you can take that 7%, either move the decimal point over 2 places, or you can take any percent that you're given, divide it by 100, and that's the same thing. So I could either multiply this by 200 times 1 plus 0.07, or 200 times 1 plus 7 over 100. It's the same thing. I typically will just do this. So we end up with 200 times 1.07, and now we just put that in our calculator. We get the same answer, of course. So that is the one-step approach. That is the percent change formula that I want you to use moving forward. Pretty much never do this again. I'm going to be very opinionated about this. Never do this again. I do not see any value in it. At best, it's somewhat more understandable, I guess, but at its worst, it's longer, it's more complicated, and it just doesn't stand up well when you get to more complicated problems, as we'll see. And in fact, in the next videos, I'm going to walk through situations where this fails, and you'll see how this new method is just so much quicker, so much more direct.